This is where we were in the last video. I asked you to find the critical points of this function given these constraints. Alright? Now, here I told you that the locations I got were 3/2 or 3/2, 0, -1/2, and then -3/2, 0, -1/2. And I went through the steps that you would take in dealing with it. So, let's see how we deal with this thing. We know that the gradient vector of the function is equal to the Lagrange multiplier, lambda, times the gradient vector of the constraint. So let's see how it goes. What's the gradient? Oh, it should be upside down triangle, nabla. What's the gradient function? The gradient vector of the function is going to be delta f by delta x in the I direction plus delta f by delta y in the j direction plus delta f by delta z in the k direction. So nabla f is equal to, let's see how this goes. When you differentiate with respect to x, you get 2x, 2xi plus, when you differentiate it with respect to y, you get 4y. So it's 4y in the j direction plus, when you differentiate it with respect to z, you get 1. 1 in the k direction. Good. When you are going to find, we're going to find the gradient vector of the constraint g. So it's going to be delta g by delta x in the I direction plus delta g by delta y in the j direction plus delta g by delta z in the k direction equal. So delta g equals, alright, 2x it would be, when you differentiate with respect to x, so it's 2x I plus -2z. Well, since it's a plus, it would be a minus. Since it's plus negative, it would be minus. No man, we're differentiating with respect to y. Where it says that, well, it would be a 0y. If you consider it there, 0y. We differentiate 0, you get 0 in the j direction plus, and then delta g by delta z -2z, so it would be a minus 2zk. Alright, good. Now, rewriting the formula delta nabla f equal lambda nabla g. So nabla f is equal to lambda times nabla g. What we have is 2xi plus 4yj plus k is equal to lambda time, then we have 2xi minus 0j minus 2zk. Alright. So of course, if we remove the bracket and multiply out the lambda, what we would get, lambda times each lambda this plus Let me make some space between them for the lambda. Lambda that and lambda the other. Alright, so we equate the coefficients. Well, you could, if you want, write 2xi is equal to lambda 2xi, but the i's will cancel out later on anyway. We have 4yj is equal to negative 0 lambda j, and we have 1k, well, 1k is equal to negative 2 lambda zk. Alright, so we have all of those things now. So we're going to deal with them here. Can cancel down. The I will cancel I. 2x will cancel 2x. Well, so based on what you see, well, let's call this equation 1, equation 2, equation 3. Oh, don't forget the constraint equation. What is it again? X squared minus z squared minus 2 equals 0. So x squared minus z squared minus 2 equals 0. So this is equation 4. Alright, now 4 simultaneous equations. So if we cancel down 2xi, cancel 2xi. So what we have is that lambda is equal to 1. Okay, good. So this is from equation 1. Let's see what we can do with equation 2. J would cancel J. By the way, oh my, yeah. The thing is, this is 0. So 4y is equal to 0. So you can say y is equal to 0. That's what would happen. Alright. Equation 3 now, what can we do with it? Well, k will surely cancel k. So we don't have to worry about k anymore. So this is saying 1 is equal to negative 2 lambda z, but lambda is 1. Right? So we can say negative 2z, because lambda is 1. So if we divide both sides by 2, z half would, negative half would be z. So z would be equal to a half. Well, negative half. Z is negative a half. Well, let's substitute these into equation 4, the constraint equation, and find x. So x squared minus negative half squared minus 2 equals 0. So x squared minus, well, this would be a quarter minus 2 equals 0. Quarter minus 2. This would be equal to negative a quarter minus, if we multiply the bottom by 4 we get 4, if we multiply the top by 4 we get 8. So x squared, oh, I shouldn't write equal, because I might make a mistake here and not see that this is on the left. So let's rewrite it this way: x squared minus a quarter minus something over 4, 4 2's 8 over 4 equals 0. So x squared negative 1 minus negative 1 quarter minus 8 quarter give you negative 9 quarter equals 0. So therefore, x squared is equal to 9 over 4. Good. Now, what is x? Is positive or negative? The square root of 9 over 4, which is positive or negative. Square root of 9 is 3, square root of 4 is 2. Right? Alright, so 3 over 2. Alright, good. So here now, we have x, y, and z. So let's summarize them. X is equal to positive and negative. Oh no, x is equal to positive and negative 3 over 2. Y equal, z equal, what is y? Y is 0. And what was z again? Negative half. Z equal negative half. So, seems as if we have 3 over 2, comma, 0, negative half, as 1 point, as and negative 3 over 2, comma, 0, negative half. And the other point, negative 3 over 2, 0, half. Right, 3 over 2, 0. Is it half or negative half? I said half a while ago. Yeah. 3 over 2, 0, negative half. So it's 3 over 2, 0, negative half. And negative 3 over 2, 0, negative half. Those are the coordinates for the stationary, the critical points. Alright? So, did you get that? If you didn't, I'm going to ask you to redo it. Alright? So that you get back these as the coordinates of the critical points. Alright, so remember now, let's go over the steps again. I wrote them before. So here you have the main formula. You find the gradient vector of the main function, that is equal to lambda times the gradient vector of the constraint function. And then you find, when you do that, you equate the coefficients I, j, k, and the constraint. And then you determine or you calculate the location of your x, y, and your z. Alright, so that's it for now. I'll see you in the next video.